we've encountered a new era in movie making, okay? Along with reality TV, which is a big part of this business right now, and documentaries and multiple cameras, we've moved on to another plateau as far as communication is concerned. And a big part of it is ClearCom, okay? And what we're not only we're doing a couple of things here. First of all, we have Peter and Ken Wilkinson here to go over everything that is new and great in the world of ClearCom communication, and some new basic things that have come on the horizon. And I'm so glad that a lot of people showed up for this, because the one thing that we don't want to do is have this become a 600 thing, okay? Because right now, I'm sure you've all encountered the fact that there are these first assistants. It used to be the terabyte antennas. Now they're into the ClearCom world, all right? And they're going in and buying sometimes inexpensive stuff, okay, which number one might not be a problem because you basically can hear on it. I mean, you know, basically everybody knows what Bluetooth is and they can actually utilize it. But the problem is that the big thing on a movie set is we're not dealing with just one department that uses multiple frequencies anymore. We're dealing with now 4 or 5 departments that are utilizing this, and they don't get it, okay, at this particular point. And to them, I understand it's a rental for them, and hopefully, you know, some of them on low-budget movies can utilize this, but we don't want to make it their job. It's a sound job, okay? And being a sound job, it not only means that it's our department, it also means that we get to hire more people, okay, or utilize more people. And in the sense that if we have 10 or 12 ClearComs out there, we have to have somebody that has to take care of these, utilize these, know how to run them. And we all win in that process, all right? So along with being educated on the equipment that's out there, right, okay, we all want to bear in mind this. And I think this is going to be a great seminar. I mean, Peter, the last one that we had, which was frequency coordination, was, to me, amazing, really. And we did have a boom seminar, a Fisher boom seminar this past year, and that went over very, very well. And we had it for multiple days, and we had a Fisher boom here, and we still have a Mo Richardson boom in the other room, okay, which is there to be used. And I think it's very important for us to know what's happening out there, all right? And this is one way of getting to it. And the other thing is, did everybody sign in? Okay. And I think we have a pretty good turnout today, and I think you're all going to be happy and surprised and well educated. And without further ado, I'll leave it up to these guys, all right? Thank you. Oh, by the way, and if you do have questions, I'm going to pass this around, so whoever has a question, we're going to utilize this microphone, okay? This will be our audience mic.
Oh, hey, okay. I really appreciate you guys coming out here. This is the kind of thing that I've been wanting to do for a while. This came about really, it came to a head with Hell's Kitchen, which was a show that shot, I think, a couple of summers ago, where they were looking for a intercom operator to come up for the show, and I could only recommend a handful of Local 52 people that I knew. And so I wanted to change that. I think, you know, I agree completely with Frank that this is something that should be in Local 52. We'll go into some details about when it's appropriate for the camera department to run the intercom and when it becomes a local 52 jurisdiction. We'll talk about that as the seminar progresses. Really what I want to accomplish today is at the end of today, I want everybody to feel comfortable with the intercom terms and communications terms, and I want people to feel comfortable setting up a free speak intercom from scratch, more or less. How you conceive of why you set certain settings and then actually applying those settings. Which is why at each workstation you see a complete free speak system. And we've included a network switch, so if anybody has a laptop, they can plug into the switch and play along together. So, I think I will tell you that I, like you, am a sound person, and I came to communications as a sound person, which leaves huge gaps in my education. And so we are really lucky to have Ken here, who has a much more formal training in communications to fill in those gaps. I will tell you that I will learn as much as you learn today from Ken, because there are, just like I said, huge gaps in my knowledge. I approach it like a sound person. I continue to make mistakes when I go out on comms jobs. As recently as November, I continually discover better ways of doing things, better ways I could have communicated to end users of the comm systems. And I will definitely spend a lot of my time filling in with what Ken says with my mistakes, because I think that that's really a great way to learn. I'll turn it over to Ken.
Good morning. My name's Ken Wilkinson, if we haven't met. And I'm here, Pete's got all these new toys, and I'm here to tell you about all the old stuff, because the intercom universe is way bigger than free speak, and there's a lot of universal concepts that are important to understand to be able to use an intercom system, whether it's free speak or RTS or Riedel. They all have the same underlying concepts working inside. So I want to talk first about what we're used to. Oh, yeah.
What's your background?
Oh, my background. I did my first 52 job, I think, in 2015. Boomed a feature, and then, I've been a day player mostly in this world since then, but I have a lot of experience in live television, which is where I really learned this comm stuff. It's most definitely an audio job, and I came to find out that the A1 audio engineer is responsible for all the comms, in addition to all the audio stuff we have to do. So I had to learn really fast, and it's my goal today to teach you guys what took me 2 years to learn in 2 hours. So I think I've boiled it down to the basic stuff, so that we'll talk about that for a while, and then we can translate how those concepts work into a free speak system, and then how free speak systems can communicate with other systems that you might use or you might find out in production. When we don't use intercoms, we use walkie-talkies, right? And
we were going to do a gag. So 2. Ken, can you hear me? Oh, Ken. Go for Ken? Okay. What'd you have for breakfast, Ken?
I didn't have breakfast yet.
You know what? I had the same thing.
Is this going to work?
Well, no. I think this is sort of the idea. We're trying to show the limitations of walkie-talkies.
And there are limitations. Can you hear me?
Yeah.
Hello. Yes, and there are limitations. Can you tell me what you had for breakfast?
I sure can. Oh. See, so we're stepping on each other.
Oh, no.
Yeah. So you get the idea.
You get the idea, I think. Only one person can talk at a time on a walkie-talkie. You can't talk and listen at the same time, and anyone can disrupt your call and step on what you're trying to say. Walkie-talkies are a half-duplex system in the middle there, where it's a bidirectional system, but only one person can talk at the same time. Intercoms work in a full duplex manner, where both people can talk in both directions at the same time, and everybody can hear everyone at the same time. And that intercoms are based on telephones. Once I figured out that it was telephones under the hood and learned how telephones worked, it all kind of made sense. But it took me a long time to get to that point, so I'm going to try to take you there now. This is a little diagram on the side here. This is a really simplified version of how a telephone works, super simplified. But the idea is that it has a carbon microphone and a battery in a circuit. The battery puts DC voltage on the pair of wires, and then that carbon battery modulates the resistance on that, creating an alternating current. Now you have sound waves without an amplifier. These systems were designed 50 years before amplifiers were invented. So with just a battery, you can create this audio signal and now transmit that on a line with the voltage to a receiver or a speaker that can demodulate that, and then you can hear it. You can also use transformers to take the voltage out of that and then just have a dry audio signal that you can use for any other audio purpose. I'm going to grab the other mic. Inside a telephone circuit, you've got really two circuits. You've got a talk circuit and a listen circuit. So you talk into your microphone and you listen on a speaker. In telephone terms, the talk is a transmitter and the listen is a receiver. I always thought that the handset was the receiver, but it's just the speaker is the receiver.
You had an important phrase in there, which was dry versus wet.
Yeah.
What's the difference between dry versus wet?
So wet refers to voltage on the line. Telephone, plain old telephone service, POT service, copper wires that came in your house for telephone had voltage on them. Regular audio that you guys are used to dealing with has no voltage on it. It's considered dry. So wet, it has voltage. Dry has no voltage. We can take these signals and change them back and forth using adding voltage with a battery or removing it with a transformer. But doing it with the voltage on the line with these carbon microphones is how they were able to make these signals without any amplification. And they could transmit it for a long distance over phone lines. So the same concepts apply in an intercom system. Which brings us to the 2-wire and 4-wire. This is like the most important concept to understand in an intercom system. And it's best to make the analogy of a phone, because telephone service originates on 2 wires, comes into your house on 2 wires, goes into the telephone. The telephone has a circuit in it that splits that out into two distinct paths, the talk and the listen, using transformers, and gives you a 4-wire connection. So now you've got 2 wires that feed the speaker and 2 wires that feed the microphone. These paths are independent of each other, and 4-wire audio is the audio that you've used your whole life and your whole career, where you have send and receive audio. But the telephone kind of reverse engineers that into putting everything on one line with one pair of wires with that voltage, and then sending that down transmitting that down the line to the phone on the other side, or the intercom on the other side.
This was the first confusing concept that I dealt with. I went out as a comms tech, not qualified at all, in 2002 with Larry Lowinger. Anybody remember Larry Lowinger? On comics, Last Comic Standing. And I learned the hard way the difference between 2-wire and 4-wire, because one of the most confusing things to think about is 2-wire intercoms has the send and the receive audio on the same pair of wires. And in the intercom world, the confusing thing for me that really tripped me up, embarrassingly, is that it's often on an XLR cable. In fact, it's almost always on an XLR cable. And so you see an XLR and you think, oh, that's got audio in one direction. But in the 2-wire intercom world, which if you want to look now on the back of your free speak systems, you'll see on the back there's 2-wire audio in and out on XLR connections.
So 2-wire, yeah, it does exist on XLRs most of the time, and usually it has a reversed gender because they don't want the pins sticking out with voltage on them that you might short out. So the hot side will be the female side, so you don't shock yourself.
And I learned something at a seminar, a ClearCom seminar, which is kind of cool. Why on earth would they put an incompatible voltage, an incompatible signal on an XLR connector? And the answer was ClearCom came into existence around the same time that front of house for concerts moved in front of the stage. And they needed a way to talk to the stage using the existing XLR cables they already had. So that is the infuriating answer to that question of why would they put such a grossly incompatible signal on something that is so common for us in another application.
Two things to look at here also are the different behaviors that you get between 2-wire and 4-wire communication. When you're dealing with a 2-wire system, the behavior that you get is party line behavior, the way that you talk and listen to other parties. Whereas a 4-wire system uses point-to-point behavior. We'll talk about this more later, but the nature of how you can communicate with different parties in your show is different depending on if it's a 2-wire or 4-wire system.
And I'll say, just to complete messing with your head, 4-wire connections are on RJ45 cables. So yeah, go figure that. And they're balanced connections, and we'll get into the nitty-gritty of how they're wired. But I've screwed that up myself. So, anyways, if you want to take a quick look at the back of your free speak again. This way, nobody sits for too long of a time. We'll get all the blood flowing. You'll see RJ45 connections that say 4-wire.
So what is a party line? A party line is also known as a conference. You've experienced these before if you've been on a telephone conference, or if you had a phone growing up at home and you were on the phone and your sister picked up the other phone, and now you could both talk to each other. You just created a party line. Anybody that has a handset on that circuit can talk or listen, and it's not private. You can't stop the other person from listening or talking on that line. It's shared, and it's on 2 wires. It's full duplex. You can talk and listen simultaneously, and I wrote here party line can be 2-wire or 4-wire. Party line behavior can be 2-wire or 4-wire is more accurate, but you can create a party line on a 4-wire system because you want it to act that way, if you program it that way. These party lines came from telephones. They were developed by AT&T using that carbon microphone battery technology. It can transmit long distances over two twisted pair of wires without any amplifiers. And this was a low-cost residential telephone service that you could, buy from the phone company, and you would share the line with either 3 other parties or 7 other parties, and your phone would ring, but 3 other people's phones would ring too, and they even had some clever ways of that they could give each person a separate phone number, but they shared the same line. So if you were the second party, you might get a special ring with 2 rings that alerts you that it's for you, but it rings in everybody's house that has that party line, so they could pick it up if they want to. So this existed up until the 1980s when they finally started to phase these out. But in rural areas and places where the number of telephone circuits were limited, and initially these were popular because they were less expensive. You could buy a private line too, which just cost more, but then you had that privacy. So out of those came these 2-wire intercom systems. These original systems were built using telephone equipment. Usually they were handmade, and based on the equipment and the technology that was out there. It's basically a telephone conference on a single pair of wires, usually in an XLR format. It's wet, has DC voltage on it. You can daisy chain them, and they can be wired a couple different ways. Clearcom wires their party lines in one way, and RTS is another popular 2-wire manufacturer. They have a different system or different pinout, and a little bit different features. You can see here that these belt packs are all daisy chained and attached to a power supply, and that power supply just puts the voltage on all those microphones, and when you talk, you'll be able to, everybody can hear each other, and you can hear everybody else, and you just put a button on there so you can switch your microphone on and off.
Whoa, I'm going to pass around a RTS belt pack. So take a look. Look on the back especially.
Show me what that looks like.
There's the XLR loop out. There's a connector for a headset. There's even, I think, a input for like an IFB or something like that, so you can also listen to it. It gets its voltage, like Ken said, from some kind of power supply, and can be looped from belt pack to belt pack.
Yeah, and these are great for using in the field, live production, because they're small. There's a few pieces. They're lightweight, standard XLR cable. You can deploy it in the field, and everybody can talk to everybody that they need to. A belt pack like that can do 2 channels, 2 separate channels of intercom, whereas a Clearcom can do 1 channel.
And here's a fun fact, which I think you were just about to talk about, which is your FreeSpeak and Arcadia base stations can supply the necessary voltage out of their 2-wire ports. So you can have a couple of hardwired belt packs running right out of the FreeSpeak base station without an extra power supply. And there's options to do some of the technical stuff we'll talk about later. But right now, just as a thought bubble in your head, think about on a set who might be able to take advantage of a hardwired belt pack. In other words, who doesn't get up and move around?
Yeah, good way to manage your resources. The RF belt packs are expensive, and they take up space on your antennas, and you might be able to deploy some hardline packs to some people that don't need to move around. So yeah, this is the Clearcom Encore party line. This is their current offering for a 2-wire analog party line. Pin 1 is ground, pin 2 has voltage, and pin 3 has audio. It has 1 channel of audio that you can talk and listen on. This is what the belt pack looks like. It has a talk button, and it has a call button that you can use to call other packs. Similar to this pack that's going around now, it has an input and an output. It's a loop through, and then it has a 4-pin headset output. This is not really a two-wire party line. This is a digital party line that Clearcom makes called HelixNet, and it works similarly to the two-wire, except it's digital on an XLR. So it doesn't carry voltage, but it's something that I want you to be familiar with. So it's almost the same thing, except a different transmission method. It eliminates a lot of the problems you have from analog audio, and ground loops and crosstalk, and all of those things do exist in this two-wire world.
It's my favorite thing about standards. There's so many of them.
This is what that belt pack looks like, and this has 2 channels on it. And actually, this one, interestingly, needs a Cat5 cable for 2 channels. They have an XLR cable digital pack that has 1 channel. I don't really see these out in the field, but you may run into them one day. RTS makes a system that they call two-wire party line, or TW party line. That's the belt pack that's going around now. This has 2 channels of audio. So pin 2 is channel 1 and power, pin 3 has channel 2 and power, and pin 1 is a common ground. The wiring between RTS and Clearcom are not compatible. You can't plug them into each other, but you can plug them into a bridge that will convert them to each other. Or you can plug either of them into the FreeSpeak base station, and you can select inside the software which one you're talking to, and it will change the voltage for you. This is what that belt pack looks like. This has 2 headset adapters on it, a 4-pin and a 5-pin, which is a nice option. It has an input and an output loop through. And it has some extra interesting features. You can change that loop through to be a program input, and it has a separate volume knob for that on the back. So that allows you, by using a second XLR connection, to have 2 channels of intercom plus a program signal. Here's another not really two-wire party line, but RTS has a digital party line system too. They connect with Cat5 cable. They look similar and they act the same way, just a little bit cleaner, and something else to be aware that exists but is not technically two-wire. There's some important concepts with a two-wire system that you need to be aware of. Nulling is one of them. When you start putting all these belt packs together, you can get echo and weird stuff that happens just because of electrical, I don't know, what's the word?
It's because it's current-based, sending the signal current-based, and needs transformers at either end. You literally have to null the transformer so that the incoming audio exactly cancels the outgoing audio. If you don't null, and this is what I learned the hard way in 2002 on the comic standing job, you get an echo. Where people hear each other, and I'm sure, Ken, the next slide will be the other thing that you have to do to prevent echo. But the idea of nulling is you're finding that center point in the transformer that exactly cancels the incoming and the outgoing audio. Because remember, two-wire means it's incoming and outgoing on the same pair of wires.
Yes, thank you. Yeah, you got to find the balance between the talk and the listen on the combined circuit. So what the idea is, once you have built your analog party line system and all of the components are installed, then you null the circuit, and it performs some equalization to try to equal everything out so that there's no echoes and everything sounds like a normal conversation. Most of these systems have auto null features on them now, so once everything's connected, you can press the auto null button on the power supply, give it 30 seconds to do its thing, and if you had any echoes, they probably went away. Another thing to consider is side tone. Side tone is you hearing your own voice when you talk. When you build a primitive party line or primitive phone circuit with that carbon microphone, everything just goes into that line, and you kind of can't separate it anymore at that point. So you end up as loud as the other party on that line. But when you hear yourself that loud, it sounds too loud to you. This was a problem for the phone company because people would hear themselves, they go, I'm talking too loud and I have to speak quieter. So then they'd speak quieter and it would modulate the line less, and then this would cause transmission problems because there were no amplifiers and you're sending a smaller signal down the line, and the signal degrades and you have losses. And they needed to find a way to keep the signal to noise ratio as strong as possible. So eventually they came up with these ways to control the side tone using transformers, a hybrid transformer, which kind of uses phase cancellation to take the input and subtract it from the two-wire circuit. It doesn't take all of your voice out, but it takes enough of it out that you can hear yourself as a confidence check, and that you'll project just enough to give it the proper modulation. So modern digital systems don't need that subtraction, but you can usually dial in the side tone that's in a menu, and to if you want a little more, you can have a little more. If you want a little less, or if you don't want any, you can turn it off completely. But the analog systems, the side tone is dialed specifically and to.
Yeah, I mean, I think
Yeah.
it's for me, it's a comfort. So I think Ken's absolutely accurate. Like side tone back in the telephone days was meant so that an end user would modulate their voice accordingly, to maximize signal to noise ratio. In modern times, we'll go through the GUI. You determine how much side tone the end user hears. I know as an end user, I like to hear a little bit of my own voice, but not too much. Other people want to hear a little more, and other end users don't want to hear their voice at all. So it's an important thing to remember. For me, it's a kind of comfort that I know the system is operational.
Yeah, it's a good confidence check to know that the line is working when you can hear yourself. If you pick up the phone and you don't hear yourself, you know the phone is dead, right? So similar idea there. So if somebody asks you for side tone, you may need to go in and make an adjustment on their belt pack in the GUI to adjust how much side tone, or perhaps in the belt pack itself, and turn that up or turn it down. Intercoms can also do tally signals. Tally's just an audio or visual indicator that voltage on a line can indicate. A phone ringing is a type of tally. You can use tallies to tally cameras, and where the camera lights up red. It's just like a 5-volt signal, but tallies can be used in intercoms to light up an indicator light on a key that you're talking or listening to that person, or to call that person and have their pack light up so that they know that you're trying to reach them. On the 4-wire side, you've got the talk and the listen. You've got 2 wires for talking and 2 wires for listening. 4-wire audio is dry. This is the audio that you're used to using. You have a send and a receive. It's conventional balanced audio. Could be unbalanced too. It may be digital. It could be patched in a Dante field. It could be patched on a MADI stream. It could be AES. At this point, it's just audio, and it could be any source or any destination. And you can use it to interface audio with a mixer, out of an intercom, or from a mixer into an intercom. So what's a matrix? RTS says it's a system where a large number of individuals have the ability to establish private individual conversations at the same time. It's basically an audio router. It's really a mixer, and that you can use to establish communication. I don't know if you can see this on this little, what these things say here. This is you, neighbor, pizza joint, and gas station. Everybody has a talk path and a listen path on either side of this matrix. And these X's are cross points where you can talk to the gas station, and by establishing a cross point between those 2 lines.
Does anybody recognize this kind of cross-point system as a Dante controller? So yeah, same idea. Does anybody have questions? I saw some maybe questions. Hang on one second. I'm going to run the mic to you.
Thank you. So the 2 wires are always wet and the 4 wires are always dry?
That's correct, yeah. The 2 wires only work because they're wet.
For voltage.
Once, yeah,
Because that's voltage.
because, yeah, if the voltage goes away, that circuit fails to work.
All right.
Yeah.
Thank you.
That's the only way the microphone works. The microphone doesn't work without any voltage on it.
Anybody else with questions?
So is 4-wire the current standard, or is it either or depending on?
It's either or, and we're going to talk more about that. 4-wire is what you have inside a matrix. 4-wire is anything that you have in your world that has to interface with anything else. Conventional audio is 4-wire, and the only 2-wire out there is really these types of intercom party line systems like the RTS that's going around, or that ClearComm Encore system. Those are standalone systems that you can deploy really quickly in the field.
I would say anybody that's run a hard wire to a boom operator, does anybody do that these days anymore? Good. Where you have their microphone coming back to you and you're sending them audio, that's a 4-wire system.
That's a 4-wire, yes.
Or 4-wire circuit, I guess I should say.
We'll talk a little bit more about the difference in how they interface with each other. So in the 1950s, McCurdy Radio Industries started to manufacture the first analog matrix intercoms. And you had a talk and a listen path inside this, a 4-wire path, that a cross point would be created. When you press a button, it would close a relay that would make contact between these 2 paths and create a communication circuit while it was depressed. So the cross points were physical and the relays were physical. And because of this, they were kind of limited in how big they could be. This thing called square law became a problem where, you have a 3x3 matrix, you only need 9 cross points physically. But here's a 9x9 matrix, you need 81 cross points. And each one of those cross points takes up space and copper and relays and switches and rack space. So as intercoms got bigger and had more inputs and outputs and more cross points, they would exponentially get larger and heavier and more expensive. In the 70s and the 80s, microprocessors helped to make the intercom systems smarter, and they could use data to communicate with remote key panels and kind of give some feedback and routing ability for point-to-point communication. But the square law thing still applied. In 1988, McCurdy made a 350-port matrix for NBC for the Olympics, and it was 10 full racks and weighed 2 tons, 20 kilowatts of power. The thing was huge. And that was like the biggest one they ever made because it was just too big. But by the 90s, digital intercom started to become a thing. Telex, who makes RTS, they acquired McCurdy, and they took over that technology. And using TDM, time division multiplexing, they were able to do digital transmission and really shrink down the systems and eliminate the square law problem. So now you could have a 350-port digital matrix that's just 6 rack spaces. Here's a little example of time division multiplexing. Kind of chops up the signals into different packets and arranges them in order in time slots that become decoded on the other side. This is how cable television works and how they're able to get hundreds of channels on a single coax. It's using TDM. So they were able to do this with voice signals. The phone company did this as well for transmission of telephone calls. And this is how they could get thousands of calls on a single coax cable as that technology progressed. So at this point in the 90s, the system started to get smaller, more compact, and more powerful. So now you have a digital matrix. And the difference between an analog matrix and a digital matrix is that you're not just making a cross point between two parties anymore, but now you can put a volume control in between those two cross points digitally. So it really turns it into, it's less of a router and more of a mixer. Now you can mix different levels of different signals all to one party or another party. And you can program how the behavior of these things, and you can restrict people. So, and this is kind of one of the things that, as an operator of a comm system, that you have the power to build those controls about who can talk to who and in what circumstances to kind of streamline the communication. So this is where these things started to come in and really allow you to define and refine how people can communicate on the show. RTS makes some matrices. The Atom is probably the most well-known system they make. The Zeus and the Odin. The Omnio is the newest one on the block. It's this little skinny one here. And you see that one a lot on new installations. It's pretty powerful, and it's small, and it has RF capability and whatnot. Clearcom, they make matrix as well. Oh, let me go back. The RTS really became popular for live broadcast production when it came out, whereas the Clearcom kind of took over in the live entertainment world, houses of worship, theme parks, and has some footprint in broadcast, but not nearly as much as the RTS. They have the Eclipse digital matrix. The Arcadia is like a small box that they make now that's popular, and it's a mini matrix in like one rack space. Very powerful. And then Riedel, these guys are becoming more and more popular. Have the Artist series matrix. It's a German company. They became popular in the 90s when they started to do the comms for Formula One and Olympics and FIFA, and they're very popular in Europe since it's a local company there. But these systems are becoming more and more popular in the United States, especially in entertainment. The Bolero belt packs, which we'll talk about, are equal, if not, surpassing the free speaks in the market at this time.
Yeah, I think the next seminar that we have will be Riedel-centric as opposed to Clearcom-centric, because it is something that we all have to know as well. But one key point I want to make is all of the ideas and terminology and concepts that you learn here today will apply to the Riedel system. So this is, we're building, we're building on concepts here.
So some concepts that you have to understand about a matrix, or that a matrix has ports on it. A port is a collection of inputs and outputs. Every port has, ports are 4-wire by nature. There's an input port, which is the listen path. There's an output port, which is the talk path, and then there's a data port, which can send control information. In 4-wire systems, usually they'll attach those with RJ45 connectors, so you can connect all 6 of those paths on one cable. So when we're talking about matrices, it's point-to-point behavior. In point-to-point conversations, you're speaking from one port to another, which are private, and nobody else can hear that conversation, unlike a party line where everybody is in the same conversation. You can have one key panel speak to another key panel, or a key panel speak to a belt pack. Or a key panel can talk to a party line. So the matrices are point-to-point by default, but they can be caused to act like a party line if you want to be able to talk to everybody. Like here, you can create a party line conference in the matrix. That's a function in the matrix, and add users to it. So it's kind of a virtual party line that's created inside the matrix. Even though there's no two-wire happening, you can have multiple people inside a conference that's housed in the matrix. And at that point, if you put a party line that you created in the matrix on somebody's key panel or belt pack, anybody that talks or listens to that party line is now part of that party line.
I don't know if this is helpful or not, but if you picture a matrix where you have a bunch of cross points, a party line are just the permanent engaging of those cross points
Yes.
for a group of people, right? So now we're sort of coming onto the idea that from this matrix, from this point to point, we've created a channel, and I think that's sort of like the next concept. Do you guys follow? Do you guys have any questions? This is all abstract, but I promise we'll sort of start to dig in with the stuff on your desk.
All right. Here's some key panels that are used for matrix. This top one is a RTS key panel. Each one of these 32 keys, if you push it up, you can listen to that port, and if you push down, you can talk to that port.
I have a question.
Yes.
My knowledge, I've never deployed a matrix system. I've certainly created point-to-points within the ecosystem that you have on your desks, but like, how are these typically used? Like, how can somebody listen to all 32 channels at once? Like, practically, who uses this and how are they used?
Well, in the type of productions Local 52 might be involved in, you might see something like this on a competition reality show, where you have a control room where the director is sitting in the control room, producers are in the control room, and they're not going to move from that position, and they have to be able to communicate with a lot of people on the show. So on their key panel, they'll have a camera PL. So this would be a party line that we can create in the matrix. We're going to take every camera operator's either belt pack or their hard line party line and group them into a camera PL so that they can talk to all of those people or listen to them all at the same time.
So you said a bit of jargon there, which is helpful, I think. PL is just short for private line.
Yeah.
Yeah.
PL, I think, private line and party line are not really the same thing. I think it's
Did I say PL is short for party line?
party line, yeah.
Right. Sorry.
So yeah, you can have a key for that. You can have a key for your production party line. You can have a key to speak to your sound mixer. You can have a key to talk to your lighting director, and a key to talk to any other department you need to speak to. So you can listen to the channels that are pertinent that you need to listen to do your job, but you can only then talk to the other people that you need to talk to when it's necessary to do that.
I see. So it's not that people are listening to all 30 channels at once.
No, you don't need to listen to all 30 at once, but you're going to many people need to listen to more than one channel at a time.
Got
So a key panel like this can give you 12, 16, 32 different places that you can talk or listen to at the same time.
And
Yeah.
forgive me if I'm jumping ahead, but does that mean there should be an etiquette for how people, like, how do I know if I'm listening to 5 things at once, how do I know how to respond?
That's a great question. Yeah, it's, when you're on a walkie and you know who's on your channel, it's pretty easy to not identify yourself. But when you're on a party line or when you're on a matrix like this where there are 50 other users or parties out there, who do you know? If somebody talked to you, I don't know who that person was, and I don't know what channel they're on. So it's really good practice to press that person's key you want to communicate with and say their name, and then say who you are, and then tell them what channel you're on, so that they know where to talk back to you. Otherwise, you might just be looking at that thing and go, I don't know who that person was. Yeah.
Hang on one second.
So like when somebody calls you online, you have your 32 lines open, like my director will have 3 or 4 different people at a time open. They're not always speaking at the same time, but they'll have the listen up. Like you said, you could key up to listen, down to talk. So you could key up and listen to anything anybody's saying on their headset, or you just leave it off all the time. And most people, when you're calling into the director, it lights up from where it's coming from. So the panels themselves, especially the new ones, are way more interactive. So once everything is programmed with the GUI, it's kind of set and forget.
I wanted to have a couple of notes, and I'll get to you, Ken. So GUI, graphic user interface, can refer to the how we program these systems for the end user, and they can also refer to what the end user sees on their individual panels. The other thing that I think we're really getting to, I don't know how you all feel about communications on a film set when film crew are face-to-face, but you start adding devices in between film crew members, not all film crews, and communications really can be especially challenged. And so I think a thing that we're really, we haven't said yet is only give people the communications they need and keep it simple. That's something that I've learned so many times the hard way on a film set. So, you know, for example, the director may never need to talk to the lighting department, the electric department. Don't give them that ability. If they want to point to the DP, that's fine. But let the DP talk to the electrical department if that's what they want. So, I mean, I think part of what I think about and what I want you guys to take away from this is who needs to communicate with whom, and only give them that. It's sort of like when the police pull you over, only answer the question that they're asking. Not that I've known that from personal experience. Yeah, and one thing I wanted to note, so you can start to think about these for creative uses, like Ken, you mentioned on a reality show, one of the sound supervisors that I work with put like 16 channels of wireless mics on these key panels, so that, you know, because a lot of times on a reality show, the story producers want to follow individual characters, and so, you know, there's no law that says these key panels need to be used for communications. At its heart, it's audio. Just like, believe it or not, that free speak base station that you have in front of you, that's an audio mixer. So.
That's true. I'm getting to both of those things. But who to talk to and who needs to speak to who, I had that in the beginning of the presentation. I moved it to the end. But it is important. Think about that.
I know, I did see one question. Hang on one second.
So I was a comms operator for like 20 years at ABC. I just wanted to point out a couple different things that you mentioned about the interdepartmental thing. The RTS belt pack that you have there, like an interesting use for that would be one panel, one key of that belt pack would talk to the director, but the second key, you could route it to the lighting board operator. So that's a private conversation that you would have there. Also, that RTS belt pack that you handed around has a third input that you can put program in there. And there are jumpers inside that belt pack that you can make that happen.
Question is then, okay, so if you have all this kind of stuff set up as far as who would want to talk to who, but what if there's a situation where they would have to talk to another department that isn't already set up on their own belt, and it's like a really like spur of the moment type of thing, and it's something like that? Is that something that then they would kind of talk to you and for you to set up to do that?
Yeah.
And then how does it change on their belt though? Or is it like you let them know, okay, now I changed this setting to that person, so now that's that person right now. So if you switch back to that, it's now the department you want to talk to. And then when you're done, let me know so I can switch it back. Is that the kind of conversation that would happen?
Yes, potentially. You can, as the operator, you can log into the Free Speak base station with an IP address and address anybody's belt pack and change the channels that they have and change the behavior of how their pack works and who, if they talk or listen or can talk or can't talk, or so somebody might make a request, and that would be your job to go in there and find their belt pack and give them the channel that they're looking for.
Here, I know I don't have a mic, but I'll. When you're operating these jobs, how do people know how to get a hold of you to make those requests?
Well, you can have a comms channel, which is great if you have a matrix system and you have key panels and you have an abundance of keys. But if you have a free speak and you've got 4 channels, you might not have room to give them a comms channel. So you might just need to. You could put it on an audio channel. Maybe just give everyone an audio channel, a public-facing audio channel, so that you can talk to comms and audio together. But yeah, you have to. That's part of the strategy, is figuring out how people are going to talk to each other and how they're going to contact you to make changes.
I think, as we go forward, a lot of you, most of you have free speak intercoms on your desk. And one of you, and plus us, have the next generation of Arcadia. And I think that one of the things that you'll see is free speak is great and it's super easy, but it does have limitations. And so the newer technology allows for more flexible assignments, allows for you to listen to more things easier. So we're all sound people here. How many people know the software Wave Tool? So if you don't write this down, Wave Tool is a cool thing that came out of the live theater world. And it basically was designed to monitor 30, 40 wireless mic channels at a time. I know somebody taught me this trick. Use Wave Tool to monitor all the comms channels. And you can even, that way you can sit on your laptop and you can have a graphical representation of all the incoming audio. And that really is only possible with the equipment we have in this room with the new Arcadia system. And we'll go through some of the specific differences a little later.
Okay. So in a matrix, we can talk and listen, and with point-to-point behavior. So you can listen by pushing your key up or your belt pack. You can assign how you want the listen to work. You can listen directly to any port. You can communicate with a phone line, incoming or outgoing, but you're only going to hear, because it's point to point. If you let's say you bring in a phone call into your party line, into your matrix, so you have a producer somewhere that wants to hear, listen to whatever's happening on the director's channel. They can phone in and connect this to the matrix, and in a point-to-point world, you're only going to hear what's happening on the phone call. You're not going to hear anybody that's speaking to the phone call, because you're only listening to the input of the port when in a point-to-point situation. If you want to hear everybody, you have to create a party line with it, so that everybody that talks to that port is now grouped together in the party line, and then you can hear everybody together. And I'm not sure if this makes sense. It doesn't make sense as it's coming out of my mouth, but
I think I'll give a real-world example. Okay. I did comms on a job called the Union, ironically, which was Mark Wahlberg, and they were coming in to do a bunch of exteriors. And as they're coming in from England, as they landed, the director and the DP tested positive for COVID. So then the question became, how can they continue to shoot with the director and the DP isolated in a hotel room? And the answer was, to bring them. They had different channels on an app. So one of my goals by the end of the day is you will know how to set up remote comms on an app. So they each had their own channels that they could, the director wanted to talk to his AD department, the DP wanted to talk to the gaffer and the grip. And, we were able to do this from the middle of nowhere, like some crane in Jersey City and insert cars. I'll show pictures later. But that they were given specific channels that they could listen to and talk to and choose which channels they wanted to talk to remotely.
I think what I'm trying to get to here is that in a point-to-point situation, you're listening, and you listen to a port, you're listening to the input of that port. You're not hearing the output of that port. And in a four-wire world, those are two distinct paths, so the output might be different than the input. But you're only hearing the input in a point-to-point world. So if you want to hear the output, you have to listen to it party line style by adding it to a party line. This is a little abstract, and it's hard to understand unless you run into it.
We'll program it. We'll make it less abstract.
And then you can have utility listen sources where you can take audio signals like Peter was talking about and putting those injecting them into ports in the matrix and then allowing you to listen to them. It could be a program signal. It could be an isolated microphone or pre-fade microphone for your host. Or any other feed that you need, that somebody in the show needs to be able to monitor. You can put those in there and just push the button up, and you can hear the program or whatever else it is. It's just audio, so you can put any audio you want in there. When we interface IFBs into an intercom system, you can do some interesting things. And I really didn't explain what an IFB is in this presentation. Or maybe I did, and I moved this slide up, but IFB stands for interruptible foldback, and a lot of guys throw that term around in the film world in one way, but it's really something else in a different world. Electrosonics makes an IFB transmitter, which we usually use just to monitor sources, but in live production, IFBs have a very specific usage of cueing talent in a invisible earpiece, and they can get a program feed in their ear, whether it's a full program mix or a mix minus them, and then the director or producer can key into that IFB and interrupts that program, and they can give them cueing for whatever they need to do on camera.
So the I in interruptible foldback is they're just interrupting whatever they're normally hearing to get a specific cue.
Right. I mean, you kind of build an IFB for your boom op when you build, a private channel for your boom op, and when you key into them to talk to them, you're basically made an IFB.
I would say just knowing how we talk to our boom operators, the one difference in broadcast is when we talk to our boom operators, it's on top of program. In the broadcast world, when the director talks to talent, it actually interrupts program.
Right.
To make room so that the talent can hear their cue.
And you can program these to mute the program or to dim the program a certain amount of dB, depending on your. Sometimes it's useful to dim it if you only have one ear of program. But if you have two ears of program, like a stereo headset or stereo in-ear monitors, or it only interrupts on one side, so you might be able to mute it and they'll still hear it in the other ear. So it's situation specific.
And as you get into more sophisticated belt packs like that Dante 4-wire PoE box, there's GUIs, software programs that you can go in and determine how those behave depending on the incoming audio. You also both casually tossed out and really explained well a concept that I think is important for all of us, which is mix minus.
Yeah, mix minus is building a mix for some talent that subtracts them from the mix, where they don't want to hear themselves. On site, this is a preference thing, really. The talent may decide I want to hear myself, or I don't want to hear myself, or I want to hear more or less of myself compared to the other talent on the show. But if you're doing any kind of remote feeds, a mix minus becomes essential because there's a delay between your side and the remote side. And if you feed them back on a remote line, they're going to hear themselves after they say it, which becomes very distracting for the talent. So you subtract them from their mix so that they only hear everybody else. And it manages that and makes sure that there's no delay confusing them.
How many people in this room have had to feed Zoom for some reason? Yeah, most of us. So a key idea when you feed Zoom is you don't feed the incoming audio from Zoom back to Zoom. And that is a mix minus, right? It's mix minus the Zoom.
Mm-hmm.
And one thing that kind of blew my mind and also cements the idea that this really is just an audio mixer is in the four-wire situation, natively, the audio that you're sending to the four-wire party line does not come back to you on that same four-wire circuit. It's making a mix minus of the audio that it's sending back to you.
We're going to get to that in a minute.
Yes, sorry.
But that's where those transformers come in, where they kind of remove you from the two-wire. You mentioned Zoom. Zoom is a party line with video. So if you understand how a Zoom call works audio-wise, you'll understand how a party line works. Once you talk into that Zoom room, everybody's going to hear it if your microphone is turned on. That's a party line type of behavior of communicating. All right, back to this IFB thing. So you can build IFBs for your talent and put them in your key panels or on your belt packs. What's really useful is to take a pre-fade listen of that talent's mic and attach it to that IFB so that you can listen to that IFB and hear that talent, and you can press down that IFB and talk to them. This allows you to have a private conference with the talent offline, off air. So, you know, you can say, all right, we're about to do this, we're coming up on this, and they can respond to you, and nobody else hears it, but the director can hear it, or the producer can hear it, or whoever needs to hear it. So the way you accomplish this is use your mixer, you build a pre-fade aux for your talent, and you feed it into the matrix or into the free speak, and you assign it to, you know, kind of link to that IFB so that when you listen to that IFB, you hear the talent. If you didn't do that, you might hear the mix minus that you're sending the talent, which doesn't even have the talent's voice in it. So this is a way to kind of modify the IFB to make it more useful. Now, when you're talking in a point-to-point manner, you're talking directly to a port, but you can also talk to a party line, or you can, which will have a two-wire kind of behavior to it. You can also speak to an output that doesn't go to another user station, but it goes to a speaker. That would be like a stage announce or a voice of God. And it would only go to that point. So these are ways to establish private channels of communication by speaking directly to the person that you want. You can speak directly to a belt pack that only that belt pack will hear. Or you could speak to a party line that many belt packs are attached to. When you talk to the IFB, you're going to talk to the talent. You're going to interrupt their program feed, which is also inserted into a port on the matrix or on the free speak. And that program signal becomes what is interrupted on that channel's IFB. You can also output that to some kind of RF transmitter that comes to electro IFB receiver or a phonak, an in-ear, something like that. It could be hardline, it could be wireless, but it's taking that mix minus or that program feed you made for that talent, adding the interrupt from the director or producer, and then putting that on the output for it to be hit that person's ear. A special list is a way to group channels together. It's kind of like a VCA fader, where you can make a list of channels that when you press this one button, it's going to talk to all these different user stations or all these different ports simultaneously. So it's just a useful tool that you can use to group channels together. And matrices allow you to control access in a major way. And this is really, as the operator of the comm system, where you can come in and make the rules for how people can speak. All of those belt packs, the ClearComm free speak belt packs, can be programmed to automatically listen, force talk, not listen, not talk, one or the other. So you can really customize the behavior for how keys work based on how somebody might need to use it. And by creating different channels or different lanes for these departments to communicate with, you can give people just the keys that they need or just the channels they need to effectively communicate without giving them stuff that they don't need to just add more noise to the room.
I have a very real world example of how to make rules for people. You know, we're in the world of software controlled devices. So there's a little microprocessor in this. And for some reason, the default way that ClearComm programs these buttons when you first sort of power it on is a way that will get people fired. And what I mean by that is I can program, the default behavior of these buttons is that I can push the button and there we go. I can push the button and I'm latched on now. And so now all the shit talking that I do is heard over the entire party line. That is a way to get somebody fired. And so one of the first things that I do, and I've been trained to do, is to make the default behavior momentary so that, oh, I haven't done it yet, but basically so that you can only talk while the button is pushed. Now, the funny thing is, I think that it becomes slightly closer to a walkie-talkie, but it protects people's jobs. So there are exceptions. You know, some camera people and certainly some directors in the like reality stuff, they want their button to be like push it once and it's latched on. But every camera operator that I know pretty much only wants momentary, so that they can talk privately without fear.
Yeah, when in doubt, give everyone momentary, and if they have a good reason to ask you for a latch, then you can give it to them.
And of course, and sorry to interrupt, but of course the other reason that latch is a pain in the ass is even if they're not talking badly, everybody hears that open mic on the channel. Now, to give you a sense of how sophisticated the GUI is, and I'll show you this later, you can go in and remote kill somebody's mic if they've latched it by mistake.
Lastly, I think matrix feature are GPIO, general purpose input output. These are like tallies. They're just little voltage signals that intercoms can use to trigger other devices, like an on-air light, or tallying a camera, or tallying a fader on a mixing board, or what you'll probably see it most for in working as a comms operator is to relay a walkie-talkie, where you can add a walkie-talkie as a port on the intercom, on the matrix, and then have it, when you press that key, it sends a GPO, general purpose output, to a relay, which closes and keys the walkie.
If you were able to listen up here, you'd hear the relay click in every time I hit the A button. Oh, thanks.
Not quite.
But yeah.
It is clicking. There's an actual physical relay in there, and so that's probably the most, the biggest reason you'd use a GPIO in the field. Otherwise,
Can I talk about one
Yeah, sure.
one way? So I had to do comms on a job with a bunch of kids in spacesuits, and they were kids and they behaved like kids. It was a Disney film, and once they got in the spacesuits and once they realized that it was all going through an audio system, getting them to be quiet was a nightmare for everybody. And I'll show a video at lunch. But what I built for the AD was a special button on her pack that triggered a GPO relay on the ClearComm that went into the GPI on the Yamaha console that muted all of the kids' mics. So when they got unruly, she was able to just hit a button. It muted all the mics. The kids stopped, like talking, and then she was able to let go. That I made a friend for life. So you can really think creatively. It could be like you could trigger record lights. You could trigger like it doesn't have to be push to talks. They are just relays at the end of the day.
all right, now we have the topic of 2-wire to 4-wire converters. So when you want to put together a 2-wire system and a 4-wire system, you need to convert them to be able to do that. And there's a number of different kinds of converters out there. The most familiar one is probably an analog telephone. You can kind of see, this is a little bit of a confusing photo here. This right here is the central office, right? So this is kind of one telephone on this side, and this is another telephone on the other side. The telephone comes in here with 2 wires, gets split through this transformer into the 2 wires for your microphone and out to the 2 wires for your receiver, your speaker.
I mean, I think for me, an aha moment was that the old style telephones had a 2-wire to 4-wire converter.
Yeah.
Because the 2 wires came into the phone, and it was 4 wires with the handset that you put to your face, right? One side was the ear, and the other side was the mouth. So that's your
Exactly.
4-wire.
This circuit here with the transformers, this is a hybrid transformer which eliminates some of that side tone. Not all of it. It's desirable to have some that you know that the line is working. But it minuses the microphone from the speaker. And it does that by using a reverse winding on the transformer. You can see the regular winding on the right side and the reverse winding on the left side here. And it causes a phase cancellation, or a polarity cancellation, I guess, to remove that. Interestingly, DSP, digital signal processing of audio in general, was developed by Bell Labs in the 60s specifically for the purpose of adding more isolation and more separation between channels on a 2 to 4-wire conversion to use in central offices, telephone offices. From that research, audio DSP it's all been built off of that. So in the intercom world, you've got what's generally just called a 2-wire to 4-wire converter, and that's a little box that you can use to connect your 2-wire party line and get you an input and output that you can plug directly into a matrix. So it's wet on one side and dry on the other side because the transformer inside strips that voltage off. But it lets the alternating current audio signal pass through it. Free Speak base station has 2-wire to 4-wire converter built into it. Four of them, I think. So you can interface directly on that, but that conversion is happening inside that box.
And all the isolation is in DSP. Like that time when I was traumatized on that first job, I was dealing with like a screwdriver to find the null point.
Yeah.
And now it's all DSP.
With analog-based hybrids, you can get about 20 dB of separation between the talk and the listen path, but with DSP-based, you can get 50 dB of separation between the two. So if you go out and you buy a telephone hybrid, which we're going to talk about in a minute, which is just a way to turn a phone line into pro audio on XLRs. You can buy cheap ones that are analog, or you can buy expensive ones that have DSP in them that will give you more separation. So it depends on how much you want to spend and what kind of performance you need. So here's a telephone interface. This is a 2-wire to 4-wire converter that takes a 2-wire phone line, puts it through a transformer, and gives you a 4-wire output to plug into a matrix, but it also has data. So this is a telephone interface that the matrix sees as a telephone line and treats it differently as such, so that you can use it to make phone calls. You can dial the phone from the intercom using a telephone interface. You can have it auto pick up and auto latch when somebody calls you. You can have it tally and blink on the screen so that everybody knows that it's connected. So this is an integrated device that's meant to be part of a matrix system. Yeah.
Jen, hang on one second.
Sorry, this is slightly tangential, but I'm just curious. Whatever the new protocol for telephones is, VoIP or whatever, is that full duplex, half duplex?
Yeah, VoIP is full duplex.
Oh, it is. Okay.
Yeah, and you can interface VoIP with these systems through Dante. If you have a matrix that has Dante I/O or an Arcadia that has Dante I/O, you can connect that to a SIP server and do phone lines directly, because the VoIP is 4-wire.
I realize
through and through.
I'm making a lot of promises about what I'm going to show later, but we have here a VoIP interface into the intercom. It does the app and VoIP, and so we'll show you what that looks like. And also, I'll talk about why it's only partially useful in the way they've implemented it, where having like a dedicated device is much more useful.
This is a different type of telephone hybrid. It's usually just called a hybrid. Sometimes they're called Telos, made by a company called Telos, or a Gentner. If you do news stuff, or JK Audio, you've probably seen these. Same thing, it's a 2-wire to 4-wire converter, converts a phone to balanced audio, 4-wire. But this is just meant for general audio purposes. If you need
There are flip sides to that. So I think it's important for us to talk a little bit about the differences. Now, especially now that we've come all this way to learn about party lines and matrices and point-to-points. So I think the first thing I'll say in terms of similarity is they both run at 1.9 gigahertz, at least in terms of what we use in the entertainment industry. Riedel, I think at the moment, only runs at 1.9 gigahertz, and Clearcom, you can, the default for us is 1.9 gigahertz, and they also have 2.4 and 5.8. Let's talk about for a second why 1.9 gigahertz is a great part of the spectrum, on a film set especially. Where are our wireless mics? Down in UHF. Where is Wi-Fi? Up at 2.4 and 5.8. Where's wireless video? Usually up around 5.8. So 1.9 is a nice little sweet spot in terms of spectrum. In terms of differences besides the standalone mode, I think the Riedel Bell Pack has more keys on it, more physical keys, so that one person can talk to more channels. I argue, that's often like too many channels, too many options for somebody. But I also think that I have to talk about that. I think Riedel looks a little bit sleeker. When I'm being snarky, I say that if you look at the Clearcom Bell Pack versus the Riedel Bell Pack, the Clearcom Bell Pack has a built-in flashlight, and the Riedel Bell Pack has a built-in bottle opener, which is absolutely true. And so, but I think goes to like its kind of Euro sleek heritage in a way. On the other hand, I want to circle back to some of what you were talking about with the transceivers on the free speak. It is a proprietary system in terms of the Cat5, and each of you on your desks have transceivers with Cat5 going into the base station. But the fact that it's proprietary actually has worked out in our favor, because you're not limited to the 300 feet of distance that you would be if it were sort of IP based. So we've done comms rigs for fashion shows where they've had multiple levels of a subway station, where we're able to run the Cat5 for 1,000 feet, without worry that we're hitting that 300 foot limitation. On the other hand, Riedel's answer to that would be, we'll just run fiber. And to be fair, Clearcom gives you that option as well. If you guys want to look on the transceiver, which are sort of on those clamps, you'll see an SF port for fiber, for a fiber module. I think that's the main thing. The other thing I guess I would say is that 1.9, there are, especially in North America, the spectrum in 1.9 is rather limited, and so you can saturate the RF spectrum pretty quickly in terms of the number of belt packs that you can operate in one area. And this is where you do see a difference between the IP and these transceivers. It's 25 per free speak system as it's configured here. And if you move to the IP transceivers, which both Clearcom and Riedel make, you can get 50 in a dense geographical area.
Just real quick with this Bolero, back to this. This does use IP antenna transceiver distribution. So this transceiver antenna connects with Cat5. You can through regular switches, and then you can build a network of transceivers over a larger space to host more belt packs. How many? Can you do 10 belt packs on a transceiver?
Yeah, and I'm going to push back on the regular IP part of Riedel. One of the things that is a little bit intimidating for Riedel is the it's a kind of AES 67, which in and of itself is a kind of Dante, but basically there's very strict clocking requirements, and so if you go to Micro Center and just get like a unmanaged switch and try and use it with any Riedel system of any sophistication, you'll be very sad. There'll be a lot of clocking errors. And so, like Wyatt, we were talking about a really great vendor in town, John Duva, who, I don't know if you've come across him, but he has a bunch of Riedel systems, but he pairs them with very specific switches that are configured specifically. We can get into that later, or you can pull me aside and I can go into some of the nerdy detail. But you just got to be aware that if you are dealing with a Riedel system and it's more than one transceiver, you can't put it through a regular off-the-shelf unmanaged switch and hope it'll just work.
Your mileage may vary. These are becoming more and more popular in the United States. Folks that I talk to that use a lot of RF comms on the user side of it, people really love the Boleros. They like them more than they do the Free Speaks in terms of how they operate. I think they have 6 channels available on the belt pack, so they're a little bit more user friendly to talk to more than one, more than 4 parties, and yeah, they're just very user friendly. There's the belt pack there. You've got 4 channels on the front, on the top, and then there's 2 more channels on the side that you can address. And you've got independent volume control over each channel, plus a main output volume. And RTS makes another RF system called the Romeo. This doesn't really function standalone. It really needs to operate as an extension of an RTS matrix. Each of these belt packs is actually like a mini key panel that the matrix sees, and it programs the same way. However, they do make these neat little Omnio base stations, which are pretty small and compact, and you can use it on location to power a small Romeo system instead of having to lug a large matrix around. This is just a smaller matrix. Something like this might be 32 ports, maybe with Dante, so you can, connect to the outside world. These transceivers also use standard IP, so they can be networked as well. Here's this belt pack. These are a little bit of a pain to use because the talk and listen keys are on the top, but the screen that tells you what they do and what's happening is on the side, so you can't really see it when you're using it. But they're pretty nice. This is toward the end here. Just as an operator of the comm system, looking at the show in terms of departments and kind of who needs to talk to who, and what you can do to kind of optimize the communication between the departments. Who needs to listen to who needs to talk to who, which departments need to be able to communicate, and how can you implement restrictions on those to best facilitate those needs and to make sure that people aren't talking on lines that they're not supposed to be, or just adding confusion or noise to channels that they don't need to be on. Try to maintain the least amount of people speaking on a channel at a time by kind of building a structure that works. I like to be able to give people these ISO channels, kind of like go to 2, but you can have multiple channels like that. So you can have an audio channel that the rest of production can speak to and that everyone in your department can hear, but you can have a private audio ISO channel that just your department can hear and that nobody else has a key for. So you can have your own private conversation but still have a public departmental conversation with other departments. And a Free Speak has, I think, 32 channels of...
Yeah, I've never hit that limit.
I think you could do 32 channels. They call them channels on a Free Speak, where it can be a belt pack, it can be a party line, it can be a 4-wire, it could be a 2-wire. Whatever you make that channel, it can be that thing. So there's enough there in a basic Free Speak system that you can build enough channels for a film set so that everybody can have their own, top level channel and then even another channel and plus whatever other
I love
stuff you need.
that you're talking about this, because I think I stumbled into this by accident, or just like hearing frustration from the users of systems that I set up. And so one example of this is on a commercial I did, comms and RF in November. I realized that the director wants to talk to the camera operators, but the ACs don't want to have to wait for the director to stop talking, which is never, and they need their own channel. And occasionally the operators want to talk to the ACs, like, where's that battery or whatever. And so I built 2 channels for the camera department, one that the director is talking to the operators on, and one for the ACs. And the ACs didn't listen to the director. They could talk amongst themselves. And if the operators needed to get a hold of them on the operators panel, wireless panel, I built a button that was only for the ACs. So that's, I think, goes to what you're speaking about.
Yeah. So that's the kind of thing you want to give some thought to. If you're building the intercom file for the show, and you can start from scratch, you can do it however you want. You can build the channels to suit what the show needs, and you can change it along the way if you find a better way to do it. We talked about this a little bit earlier, comms etiquette, and just how to, in my opinion, the best way is to identify the caller you're trying to reach, then identify yourself so they know you're calling them, and then what channel you're on so that they know where to answer you. The more channels the system has, the more need that this need arises, because you might not know everybody's voice and where they're calling you from, and you hear your name but you don't know where they called you from. If you have a key panel, you might have something blinking to alert you, but if you're on a belt pack or something else, you might not have that, or you might not be able to look at it. So just be courteous and say who you're looking for, who you are, where you are, and then once they respond to you, then you can kind of address your question or whatever your comment is. I forgot to bring a cue box, but this is a really useful tool to have in your toolbox. This is a little line tester. What's really nice about this is that it has a voltage indicator on it. And we'll tell you if you have voltage on pin 2 and pin 3, so this is really helpful for diagnosing and troubleshooting 2-wire systems. It has a speaker on it. You can play, you can talk into this thing or listen to a party line or a comms line, and use it to test any audio circuit. You can send tone with it. Indispensable if you're really doing this work to have one of these, just so you can in your back pocket, because you're going to need it. A couple resources on this that you can check out at home. This book, the Handbook of Intercom Systems Engineering, is published by Telex. They make RTS. It goes through all of this stuff on a deep level, from the very beginning of what I was talking about, through the history, through the stuff they were using in the 80s and the 90s, and lots of diagrams, lots of case studies about why you would set this system up this way because these people need this, and TV examples and on-location examples and all sorts of stuff.
The pinouts in that are enormously valuable. And even like recently, I had to wire up a 5-pin output, 5-pin I/O from a hardwired belt pack to a headset that only had one earpiece. And so, how do you handle, right? The 5 pins are so you have left and right. Some people like to hear program in left. Some people like to hear comms in the right, and separate it that way. But if you only have a headset like this with 5 pins, do you short pin 5 and 4? Nope, not. And if you do that, you'll damage the device, and those pinouts are in this book. So the answer is, in that case, you leave pin 5 floating, and that's why this book is valuable and it's free.
Yeah, you can find this book on the RTS website in a PDF. It's free. I found a print copy on eBay. If you can get find one of those, I'd recommend it, because it's just a good reference to have. This guy, Rob Lipop, has a YouTube channel. He's an engineer, a TV engineer. I got to work with him once. He's a really smart guy, and he makes excellent videos about intercoms on his YouTube channel. They're short, digestible, and they cover all of these concepts in depth. And then he gives instructional videos on free speaks and and Riedels and, you know, all of that stuff. So this is a really valuable resource on YouTube. Look this guy up. He's entertaining videos with a lot of information. He's got a really interesting way and smart way of explaining a lot of these concepts, and I've taken some ideas from him because they're so good. So please check him out. And this website too, thecomsguy.com. It's all print, if you got to read it, but a lot of good information here about intercom basics, but heavy on the RTS side and how to program an RTS matrix, which may be less applicable in this, you know, the kind of work that we do here, but you might run into one day. The RTS intercom matrices are really popular in broadcast production on TV trucks, TV studios in the United States. So you might run into these one day, or you might have to interface like a free speak into a system like this. So it's helpful to understand how this works, and you can go on here, and he has lots of tutorials and screenshots of how the software, which is called AZ Edit, is programmed to program the matrix. That's it. Here's my contact information if you'd like to contact me and have questions about this. And that's a lot of stuff. So are there any questions about what we talked about?
I have two questions. One is, what is, so on a feature when it's just like the camera department using their own standalone system, which system are they using? So that's question one.
Got it. You know, that's an excellent question, and you know, I see a lot of Riedel on the higher end jobs, and with good reason, despite my personal issues. The other system I see a lot of, I used to see a lot of HME, which were those like drive-through systems, because they're simple. You certainly still see them with crane operators. But I see a lot of Hollyland now, and we sell Hollyland to these camera operators. And so I think we should talk about Hollyland just briefly. They too are 1.9 gigahertz based. DECT, D-E-C-T is the wireless standard that Riedel, Clearcom, Hollyland, RTS I think is 1.9. They all use this standard called DECT. You know, I don't know. I think that they're good enough. To answer your question about, you know, what happens when the camera department wants to get program feed into their Hollyland system or their Riedel system, you now have the concept of what to look for, right? So you're looking for. If you're lucky, it'll be labeled program in, but on the Hollyland, it'll be labeled 4-wire. And when you see 4-wire, you'll be like, aha, I know I need an adapter. And so the adapter will look like something like, you know, whatever the 4-wire connection is. Usually it's RJ45, but it'll just have an XLR male and an XLR female. You'll find pinouts in the manual, and you'll know that the, you know, because it's 4-wire, it's dry, meaning there's no voltage that you're worried about. Alex, I'm thinking about the story that you told during the break of almost plugging in an audio console into a wet intercom circuit. Which is something easy to do because, for the love of God, why did they choose XLR as the standard? Yeah, I mean, I think that's the basic, and even HME. The problem that I see in the field is a lot of the camera operators are buying Hollyland systems without base stations, and so there is no 4-wire way into them. And yeah, I mean, that's when you tell them the sad news.
I think part of this question comes into why we're doing this seminar in the first place. The real basic answer when the camera department asked to hear program in their intercom is no, you can't, because you're using a departmental thing, and if you take program, now it becomes a sound department thing, and we need to take over all the use if you want program. That's the real answer from our union point of view. Now, obviously, there may be circumstances where you feel like these poor schmucks are never going to get through this without program. I should probably find a way to help them so that they don't fall over their own feet. But at the same time, I want you to keep in the back of your mind that the real answer is no. It's our department. You guys are using something that belongs to our department, and now you're overstepping your boundary.
This might be connected to this, bringing this up. With program audio, like what kind of latency are we talking about with all these systems? Because it could be jarring if the latency is that great.
In my experience, there's some latency, but not enough to cause a disturbance. It's semi-real time. Yeah.
We'll get to it. We'll put it through. We'll put it through our own systems.
Hi. We already talked about the HME Honolulu thing a little bit. There's one other thing that you guys might run into in the field. That is older cameras or studio cameras. Sometimes will have the Telex system built into them. So you can also talk about Black Magic, which is a prosumer thing too. But just to notify, if you see like 4-pin out, or sometimes even 5 on cameras, you're not sure what it is, they're asking you, sometimes you can actually tap into that, and the HME or the Telex system is actually built into the camera itself. So if you're trying to figure out how to feed into that for studio operation or for the sort of blended narrative studio stuff that sometimes happens, you have to find where that base station is, even though there's no RF packs. They're all built into the pedestal cameras. But yeah, obviously, Black Magic is another thing where they're trying to build in now the duplex into the SDI signal in the video distribution.
Anybody else?
So in a control room style show, like a reality show or something where you need like 32 ports, let's say, who is operating and setting up the system? Is it someone from the sound department, or is it a separate specialized comms position, or is that kind of nebulous right now?
Well, a lot of shows like that are contracted with some large rental company that supplies a lot of the, technology, the cameras, the audio, the comms, to all kind of an integrated package that they might come in like Bexel or NEP or something like that, where they come in and design the whole package for the whole show and install it, and then an operator comes and stays on to operate it. The daily, the day-to-day processes of programming it and making changes for the users. But it could be an owner-operator situation too, or just getting the package from Gotham and putting it together yourself. So it really depends on the scale of the show and what.
Using Hell's Kitchen as an example, I don't know how much of this is true, but the way it was explained to me was Bexel came in, they did the programming, they did the installation, and they really just needed somebody to do the day-to-day operations. And so, like I said at the beginning, I think one of the hopes of this seminar is that you would feel comfortable enough doing the day-to-day operations. And I even had that conversation with the production manager where I said, will you be okay with somebody that's green with Riedel but understands comms terms? And they said yes. I don't know, having manned that job, whether that would actually have worked out, but.
So I did get the call for that gig, and I was frank with them that I had a lot of comms experience, but I didn't have Riedel matrix experience, that I'd be willing to learn it. I ended up taking an A2 position on that gig, and they flew in a comms operator from Los Angeles and another one from Colorado. because we don't have anybody here that really had the qualifications. So having those qualifications, you know, in New York we need some people that can do that kind of stuff, so they're not flying people in and taking work away that we could have here.
Fair, yeah. So this is one step to that. The next one I want us to do is Riedel specific.
We've discussed as far as you know, dealing with the interdepartmental aspect of this, okay, which is, you know, it's getting tricky at this particular point because, you know, they don't, basically, productions aren't being totally honest with everybody, as you well know. So when you go in to negotiate a job, and there are certain things that they're going to say, especially you, the mixer, that they want to know and they require, okay? And, you know, basically, you know, it's dictated either by the director, what he wants to do, and also the DP's involved in it, okay? And once, you know, the DP's involved in it, okay, then it becomes, you know, something of a torturous fight, okay? And that's, you know, what we're dealing with here. So what we're trying to prepare everybody for is the onslaught of what's happening, okay? And it's not only in this aspect, it happens in everything as far as, because we're dealing with a business which now has taken on much more technical things that we were ever aware of at this point. And we're dealing with the electric department, we're dealing with the camera department, we're dealing with our own video department,
Nice.
and our own sound department. And we all have our requirements, and everything is affected, especially with us, okay? Now, it's no longer where we send the boom guy out there and go, hey, don't worry about it, you can get all this, whatever. Now it's like, I need 12 wirelesses now, okay? And now you are in a panic situation because of the fact that, why do I need 12 wirelesses? You don't, okay, but this is what they want, all right? Now, not only are you dealing with the 12 wirelesses, but the fact that you're dealing with a camera department that is dealing with frequencies that are in your area, and now you got dimmer board operators that are dealing with the same thing, okay? So, I mean, it's become so complex in its, and our ability to, we're in the middle of this, all right? And, you know, the end result is, do we want to get the best sound that we can? Yes, we do, okay? And do we want to accommodate what the director wants? Yes, we do, okay? But now you got 3 other departments that are dealing with something that they think is their most important thing, okay? And we all know it's a fight. You know, solving it is diplomatic in a way, okay? We all have to be diplomatic in our approach to it, yes, but again, the end result is sound, okay? And yeah, Michael.
Just one brief thing to Larry's point about justifying it, especially when you're in the middle of a job on a set. The same thing that I've ended up doing with distribution is the same thing for playback. It's one thing if there is no quality control and it's only end users. Like if the camera department just needs to hear, just like they would get a Comtech, that's about the extent of it. Just like on a set, if somebody's playing something that has nothing to do with the shot, they just want to hear some music that's irrelevant, there's no quality control involved. You just get a Comtech, you play a sound, that's it. Everything beyond that becomes our problem. because we're responsible for the quality of the content. We're responsible with the quality. Can everybody hear each other? Who's talking to who? That is our responsibility. It would be the equivalent if you're talking to a camera department and like, hey, why can't you guys give me the sound and I'll deal with it? That's the same thing. This is what I say. I say that's the same thing as asking the DP or the DIT to work off of the monitor on my sound card. Like, I'm an end user for video. You guys should just be an end user for sound. When there's any quality control involved, that's when we need to start taking control of it. That's how I usually put it.
Sorry about the delay, everybody. I think that's a great point. If they just want program audio and that's it, you know, beyond just feeding them program and making sure it's okay, I think that's completely acceptable. You know, in my opinion. But the minute that we have to babysit it, or more importantly for me, the minute it goes beyond, you know, when the DP says, "Oh, I want to also talk to the lighting board operator," or "I also need to talk to the grips," then it becomes a sound person, and then it becomes, in my opinion, an operator, because the minute that you lose comms, everybody gets up your butt. And so that's not a fair position to put yourself in if you're busy getting good audio.